It's working perfectly. So hello, everyone. Thank you for coming to our networking and workshop event for the AI against COVID competition. We are very happy to have Mr. Adel and also Professor Wang to have two different talks in related to AI. And then we will go to another virtual venue to have a small networking. So it will be a virtual venue called a Spatial Chat. We will send you a link in the chat box, and then you can change your space and talk to each other on that venue. Professor Wang, if you are ready and you want to start, I think we can start. Let me just make you as a co-host so you can share your presentation. Okay, Professor Wang is currently a Canada Research Chair in Artificial Intelligence and Medical Imaging, co-director of Vision and Image Processing Research Group, and an associate professor at the University of Waterloo. He is also a co-founder and chief scientist at Darwin AI. Without further ado, I invite Professor Wang to start his presentation. Thank you very much, Professor Wang, for accepting our invitation.
Sure, I'm happy to. Just let me know whenever you could see my screen.
Sure.
And we'll go from there.
Now I'm seeing your screen.
Okay, perfect. So I'm just gonna make it full screen and I'll continue. So, thanks everyone for being here today for this workshop and networking session. So what I'm gonna talk about today, it's related to this particular challenge, but from a very different perspective. So what I'm gonna talk about is more about trust and transparency in AI in medicine, which I consider as one of the next frontiers for artificial intelligence for medical purposes. And so again, the reason many of you are here is because of the competition, as well as the innovations that you aim to have in the area of AI for medicine. And indeed, there's been a lot of excitement and promising developments in AI for medicine. So as some examples, on the top left is an example from our lab where we built an AI-powered microscope that has no lenses and yet is able to image at the same resolution as a 4DX microscope while being able to get orders of magnitude larger field of view. And the reason we're able to do this is we leverage AI as computational lenses to take light coming in and digitally transform it into a histopathology image. On the bottom left is COVIDNet, which we'll talk more about in a little bit, and which I've briefly talked about in the opening. But there's also lots of other advancements in the area of AI in medicine, be it on the top right, discovery radiomics, where traditionally what people did was they looked at medical imaging data and tried to come up with clinical visual biomarkers to represent disease like cancer and so on, tissue characteristics. But here, what we've done is by leveraging AI and machine learning, we've created, instead of standard radiomic sequencers that are just based on handcrafted or hand-discovered types of clinical biomarkers, we instead learn it directly from the data to allow us to get much better tailored radiomic sequences for a particular disease. In the middle is an AI-powered system that we built called QI, so the coded hemodynamic imaging system, which allows us to capture and represent and visualize the blood flow in your body using a custom imaging system, which can only be done using this kind of approach. And on the bottom right is something you hear a lot about, which is the use of drug discovery of AI to identify new drugs and to allow us to explore much greater options. So again, lots of promises and advances in AI in medicine, and there's a lot of investment in this area. One of which is the COVIDNet open source initiative, which we've been pushing since March of last year. And again, just to kind of reiterate, it's a global deep learning initiative for COVID-19 clinical decision support, ranging from screening to risk stratification, all the way to treatment planning, open source, open access available to everyone, with the data set here used for this particular competition derived from the COVID-19 initiative. Again, we continue to iterate and improve both the data set as well as the models, and it's gotten to be a multidisciplinary team of over 20 plus people, which is now used around the world on all continents and customized for different use cases and demographics. And so we're quite happy about the global support as well as the global usage of this. And so just a little bit more detail, with the COVID-19 initiative, we've designed it from a systems design perspective to allow different parts to be integrated into the clinical workflow. So we have the COVID-X dataset, which many of you guys are using, that interfaces with the COVID-19 models for classification, as well as severity scoring. And then within that, there's automatic report generation and case management using a custom clinical decision support system that we've also made available open source to support treatment planning, to support admissions, and so on and so forth. So this all sounds great and all. So everything is promising, everything is sunshine and rainbows. But in reality, when trying to apply and deploy AI in real life situations, it's not all sunshines and rainbows in practice. And it is something that we really want to keep in mind, especially when we're trying to design systems such as the one that you're doing for the competition, so that later on it could be deployed and used in real world situations. And so what do we mean by this? An example that I always like to give is the one on the left. And so what you see is a soccer match or a football game, but what is important about this is that during the whole broadcast, the focus was never on the actual action. It was never on the actual soccer ball. It was never on the players playing. It was always on the referee. Through the entire game, all it did was track the referee. So then the question is, okay, great, it's leveraging AI in the wild. It's trying to use AI to capture what's important in the game and show it to the audience. So then the question is, why does it always show the referee? And so what they found was that the AI algorithm, which worked really great in theory and during development, was actually detecting the referee's head, because the referee's head is bald, as a soccer ball, and tracking that head through the entire match. And so that's where the reality of the AI really sets in when it's used in practical situations in the wild. And so there's many special considerations that we need to take into account. And one of the most important bottlenecks to operational AI, especially in medicine, is just the level of trust. It's really very, very difficult to figure out how and why an AI model makes solutions the way they do, how they make decisions, and how they make predictions. It's very difficult to know if and when it runs reliably and dependably for different scenarios. It's hard to know if it's biased and when it's biased, and it's hard to know where the errors stem from, both from a model perspective as well as from a human perspective. And so with all these difficulties, it makes it very difficult to deploy AI in the wild in a very trustworthy manner. And so where this trust breaks down, and so there's been many different scenarios where trust breaks down, where the wrong decisions have led to big consequences when it comes to AI. So in a very famous study, what researchers have analyzed is they analyzed the AI algorithms used for determining who deserves extra care that was actually used to conduct a risk assessment on hundreds of millions of individuals each year to determine the level of treatment they should get from a clinical perspective. And what they found was that millions of African-American individuals were actually affected by racial bias in these healthcare AI algorithms. And the reason for this was when they looked at past data, what they found was that historically less money was spent on that particular demographic. Therefore, the AI learned that even at the same level of severity in terms of the condition, individuals who were Caucasian received greater care and were more likely to be recommended. In another very good example is when it was used for face recognition. And the very famous one where there was a study where they took the current members of Congress and pass it through a face recognition system for determining whether they were criminals or not. And so many of the Congress individuals were actually detected as falsely as criminals. But what they also found was that there was a significant racial bias where individuals who were people of color were more likely to be falsely matched as criminals. And on the right, which is actually becoming a very big concern from a clinical AI usage perspective, is the notion of adversarial attacks, where very minor adversarial perturbations are being applied to data, in this case, images, and causing completely different decisions. So it's fooling the actual AI models to think it's one thing when it should be another. And this has very big ramifications, especially from a clinical perspective, could lead to significant effects on the patient population. And on the bottom right is an example of an adversarial attack where by putting on these adversarial glasses, what you see on the bottom right, it's able to turn Daniel Craig into Meg Ryan for the AI model. So it's very similar to when Superman puts on glasses and when takes it off, suddenly becomes Clark Kent. And last but not least, another example that was in recent years was the use of super resolution AI, where here you had a low resolution picture of former president of the United States, Barack Obama. And after super resolution, it creates a very convincing high resolution image, but it's that of a Caucasian male. And so all of these really brings to the potential challenges with AI in medicine, which is gaining the trust of the clinical community as well as the people they serve. And so what do we want to do? What we want to do is we would want to make sure that AI is making the right decision for the right reason. And so what doesn't it always make the right decision for the right reason? The answer is no. It's actually far from the truth. And that's where trust can potentially break down. And so here's an example of a self-driving car case where the neural network here is using the environmental information to determine how it should steer. And so in this, what we found was that in this particular case, by doing further analytics, what we found was that the actual deep neural network never looked at the road, never looked at the lane markings, never looked at the lights, never looked at the street signs. All it did was identify things it should not crash into and avoid crashing into them. So essentially it was playing reverse bumper cars. And so that's a perfect example of where the right decision is being made. Like the error of steering is actually really, really amazing, but it was all for the wrong reason. So imagine you went to purchase a car and you asked the salesperson, okay, great. How does this self-driving car AI work? And they told you that, it works beautifully. What it does, it looks for everything it doesn't want to crash into and it steers away from it. And so how do we actually deal with these kind of situations? And that's where the notion of explainable AI really becomes important. It's no longer treated as just a buzzword. It's actually very important, especially with all the regulatory compliance as well as policies being put into place for algorithmic transparency. It's about opening the black box of AI for greater transparency, greater insights, as well as greater trust in the solutions when they're deployed in the wild. And so an example is the one that I just showed you, where we did use our explainable AI, our quantitative explainable AI approach to identify that in this particular scene, the steering information, all the steering predictions were based on as you can see, the post in front of the car, which is highlighted in red as a critical factor. On the right is a very interesting example where we were able to help a partner with their AI for detecting garbage cans. So they had a great prototype where it was able to really identify garbage cans with very high level of accuracy. But what we did was we used quantitative explainable AI to analyze it. And what we found was that it never looked at the garbage can. All it did was surprisingly identify animal faces. And when they went back to look at the data, what they found was that most of the data were garbage cans, but had a possum in it, had a dog, had a cat, had a rat, so on and so forth. And these are the kind of insights that you gain to help improve your system. And so what on earth is quantitative explainable AI? And so the notion of quantitative explainable AI is to move away from the buzzword nature of explainable AI, where we have a bunch of saliency maps where there's certain areas that are highlighted and you kind of have to put in your own interpretation just to interpret the actual interpretation itself. Here with quantitative explainability, what we're able to do is really unveil what is the critical factors involved that led to a decision by the AI, and in a way that can be quantified in terms of it actually did make a decision-making insight. And so on the left, what you see are some examples of quantitative explainability in action. So on the top left is a picture of a fighter jet. And with quantitative explainability, instead of getting a saliency map, what you actually see is a specific region, a highlighted region, right, that says it is making a decision based on, in this case, the front of the jet plane. And not only do you have that, you can also get the quantitative justification for that explanation. So the quantitative justification returned by the quantitative AI, explainable AI algorithm, is that based on this explanation, the model predicts it is a warplane with 98.7% certainty. Otherwise, the model had thought it would have been a parachute with 23.5% certainty. And so with this quantitative justification, not only do you understand what drove the decision, but you also understand the rationale behind the explanation itself. Similarly, on the bottom, you see a meerkat. And so what it did was the explanation was that we thought it was a meerkat because of the face as well as the front of the body. And the justification being that based on this explanation, the model predicts it is a meerkat with 97.4% certainty. Otherwise, it would have thought it's an ostrich with 67.6% certainty. You know that it is an explanation that actually reflected the decision, because without this explanation, or what was the critical factor of the explanation, you would have gotten a completely different answer. And that's where the quantitative nature becomes very important. And this is when we compare to other approaches that are quite popular, such as Lime, Shep, and so on and so forth. What you can see is that by taking a more quantitative explainable AI approach, you could actually get explanations that are a lot more interpretable and a lot more clear and related to the actual decision-making process itself. And so what you see on the right is Lime and Shep for the exact same situations. And as you can see, the explanations require significantly more interpretation, as well as there's many more fluctuations. And it's not grounded in the fact that these particular critical factors, as explained by the explainability, does in fact lead to the decisions. And so what are the multiple facets of quantitative explainable AI that can really help from a medical case? One of which is the decision level insight discovery that you could gain from this kind of approach. So here's an example of where we're using it for patient finding, where we're essentially identifying, in this case, patients and predict their progression in terms of pulmonary fibrosis. So what is the predicted level of lung function decline given their current state, and what it will be in months or years ahead, because by able to identify them ahead of time, that you'll be able to identify that these are the patients that need a particular type of treatment. And so it's good and all, and we could have just done it, the prediction, without analyzing it, but it doesn't give us the insight and assurance that it's making the right decision for the right reason. So in this particular case, what you can see is that with quantitative explainability, we're able to understand that the AI model for predicting lung function decline months or years ahead is actually based on relevant visual indicators in the lungs that a clinician would use. So things like ground glass opacities, and in this case, you can see honeycombing patterns. And this gives a greater level of trust, both from a patient perspective, but also from a clinician perspective. Similarly, this can be applied for model auditing during the development process. So as you're on into your the actual competition itself and you're building models, it always gives you a sense of assurance to be able to audit your models to ensure that the right decisions are being made for the right reasons and gain new insights into the problem. Imagine you built your entire system and it had really great sensitivity and great specificity, but it was not leveraging anything in the lungs. And so here's an example of it being used for, let's say, skin cancer cases, identifying the key areas in the lesion to indicate that it's melanoma. On the bottom left is a COVID case, except it's for CT scans, where explainability is able to show that it is indeed making decisions based on ground glass opacities as well as bilateral abnormalities. And on the right, which is particularly relevant for this particular competition, is a case where an AI model used to predict and detect COVID positive cases is leveraging this particular area in the left lower lobe, which corresponds to ground glass opacities. And this really helps give you assurance that not only are you doing well in the competition from a pure numerical perspective, but you're also doing well from a real world usage perspective, which becomes especially important as you get into phase 2. Another thing that is very useful at is the detection of wrong decisions for the wrong reasons early, so you get insights not just about the model itself, but also about the data. So here's an example for that case that I talked about before for pulmonary fibrosis, where using quantitative explainability, we're able to audit the behavior of the data itself based on the model and identify these particular cases that were particularly problematic in the data itself. So on the left, what you see is that unbeknownst to many, there were actually a lot of CT scans that had circular artifacts on it. And in fact, models start using these circular artifacts to make its predictions on lung function decline, which makes absolutely no sense. On the right is a situation where synthetic padding existed in the actual data set, and the models start using these synthetic kind of padding as opposed to actually looking at the lungs. And that's another situation where it really helps you from a data qualification perspective. So from a data QA perspective, very important. And another reason why this becomes very important is also to not just gain insight purely on the data, but also how it behaves with the model. So on the left-hand side is an early prototype of an AI model that we created for chest X-ray detection of COVID. And what it did was get extraordinarily great sensitivity, specificity, PPV, and so on and so forth. But when we analyzed the data, what we found was that pretty much many cases, they never looked at the lungs. They never even looked at body. They were looking for embedded text to decide whether somebody has COVID-19 or not. On the right is an example for CAT scans or CT scans, where once again, it's making really, really great decisions, almost 100% accuracy by never looking at the lungs, barely looking at the body, but really looking at the type of bed that the patient's lying on for the CT scanner. And this is a really good illustration where AI, when not guided properly, will try to game the system because it doesn't know any better. It just looks at what is the most differentiating, and in this case, it's the patient bed. Other ways that explainable AI allows you to do is pretty much do data auditing to identify biases and errors so that actionable steps can be taken. This is particularly relevant when you have a wide variety of demographic information and you would like to leverage it properly. So in an example, what we did was we leveraged explainable AI to audit data sets for biases. What we found is that people over the age of 60 accounted really just for 1.71% of the people in the entire data set. Females accounted for 31.11% of people, mainly male, were between 15 to 29. And when we look at the signups, males were associated with sports and firearms. And the number one choice is barracuda because men love to go fishing and hold up their fish for pictures. And females were associated with clothes and dogs. And so the inherent biases that we have in our data sets gets propagated into the models that we build. And it's a very important area of concern. Another very important use of quantitative explainability that is beyond just from a development perspective is on the validation side. Is once I built it, I need to validate it. And when you're building something for clinical applications, you need clinical validation. And so with explainability or quantitative explainability, it actually helps facilitate for validation by expert clinicians to ensure that decision-making behavior is consistent with clinical interpretation. So on the right are situations where we're able to use the quantitative explanations and show it to expert radiologists with decades of experience to confirm whether it's making the right decision or not. And in all these cases, fortunately for us, that the explanations were consistent with radiology interpretation. Similarly, we can leverage it for system level insight discovery, which is less about the why and how it's making a decision, but what of the decision. For example, being able to identify the most predictive factors of a client profile, for example, used for patient finding. To use another one is for drug discovery, where we're able to then identify the most predictive genetic factors that is indicative of drug response for cancer patients. So by being able to do this, this allows us to not really only understand the general behavior of the system, but it also allows us to identify what is beneficial and what is detrimental. And so in this particular case, what you see is not only do we have the most predictive genetic expression factors, we also have the least predictive. And when we actually remove the least predictive, we actually get a significant improvement in performance by focusing on what's actually important to the actual reaction of the patient to a particular drug. We've done something similar for help with model design. So in this case, we actually leverage explainable AI, this quantitative explainable AI, to really understand what's actually important and use it to build a system for predicting whether or not an individual should have ICU admission. Similarly, we're able to use it for further profiling, really understanding the demographic biases. So for example, in this model example here, the gender from a trustworthiness perspective was very balanced, which is great. But from an education and age demographic perspective, what we were able to find was that individuals with a high school education resulted in less trustworthy predictions made by the model compared to individuals with university as well as graduate school education. We also found that individuals who were 50 plus also had lower trustworthiness in terms of the predictions. And being able to understand it allows us to go back to the data and improve the quality of the data as well as the model itself. And so the key take-home message here is that huge promise, there's really significant promise in the use of AI for real-world operation applications in medicine, as you saw. However, there's significant bottlenecks in trust when it comes to AI that has been limiting its overall adoption. But there is hope because there's significant progress in the area of quantitative explainability to help us break through these bottlenecks to gain the trust of both clinicians as well as patients and different clinical institutes. And so thank you very much for listening. I'm always looking for collaborations and happy to answer any questions.
Thank you very much, Professor Wang. So if there is any questions, you can raise your hand in the participant window, or you can write your question in the chat box. So, but we invite everyone to raise their hand so they can talk, and we have around 5 minutes for the question and answer. Until we receive a question from the attendees, I have like a very basic question. So the solution to increase, like to train the model is, you say it's you need to like check your data set that you want to train your model. So to like avoid any like biased data in the data set, that will increase the trust at the end, or
Yes, that's right. So it's really a lot of times people have go one way or another, which is, okay, I'm just going to manually parse through my data and I'm going to look for problems, anomalies, or potential bias and issues. But the problem with that approach is that just the way you perceive bias, you perceive fairness, and you perceive error is different than the way an AI model does when it's learning from your information. So I've seen many situations where my data appears perfectly balanced from a quantitative perspective amongst all demographics, and yet the model itself starts learning biases. Because at the highest level, we can only see quantitative. Okay, we have an equal number of both, let's say, both classes, right? But does that mean the actual variety or diversity within each one is actually that great? Not necessarily. And so there's also the others where, oh, I'm just going to look at the model. But if you look at the model just at the high level and don't understand the data, it really doesn't tell you too much about your problem. And I've worked with a lot of, or I talked to a lot of individuals where they're essentially building based on purely top-line accuracy, precision, recall, and they never actually looked at data. They treat it as a pure algorithmic problem. And so my perspective here is that it is through explainable AI, especially of the quantitative nature, that allows us to get insight both from about the data as well as the model, as well as the interaction between the two.
Great. Okay, thank you very much, Professor Wang. I don't see any question in the chat box, nor like a raise hand. Oh, there is a question. Do you or your team have models that are already being deployed into a medical application?
A very good question. So right now, especially with the COVID-19 initiative, a lot of different institutes around the world are actually leveraging it, grabbing it, and customize it for their particular clinical needs or their particular research needs as well. And so I find that to be very rewarding as well as very important, because at the end of the day, with our initiative, we try to amass as much data as we can, but you can never get full data. You can never have all the data you need. And so therefore, having this available in open source actually is really beneficial, because it allows clinicians, clinical research, and others to take what we have and really tailor it for their specific scenarios.
Thank you very much, Professor Wang, and thank you again for accepting this our invitation. Although you have like a very busy schedule for today. Thank you so much.
No problem. Always glad to talk to people here.
Thank you very much. Okay, now we can go ahead to the next slide, and let me share my screen. So now we will have a talk entitled Data and AI on Azure by Mr. Ahmed Adel, Director on Data and AI Customer Engineering in Microsoft Canada. Mr. Adel, I invite you to start your talk. And thank you very much for accepting our invitation.
Thank you. I need to first share my screen. I don't know if you need to add me to.
I already made you as an co-host, so you should have the authority to do that. Okay. So if you try sharing your screen.
All right. So because I don't use Zoom a lot, I use Teams more. Let me know if you can see.
Now we are seeing your screen.
Okay.
Just a minute, Mr. Adel. We have a question. I think it's for Professor Wang. Mr. Muradi, I will forward the question to the Professor Wang, and probably he can send you the answer by email.
Yep, I've also sent the answer by chat, so
okay, perfect. We're good. Thank you very much. Okay, good. Okay, thank you, Mr. Adel. You can start. Sorry for the.
All right, it's always a pleasure listening to Professor Wang talk and get insights from him. The only downside is it's a very hard act to follow. So the good news is actually I think what I'm trying to cover here is kind of complementing from another angle of this story that we have here. So what I wanted to focus on today, and I know that we're already running over in time a little, so I'll use probably more rapid fire in going through this. Is some of the machine learning capabilities on Azure. And the reason I want to, this is not a marketing or a sales presentation, but I wanted to actually focus on two keywords out of this talk. So if we go with only two things outside of the following 15 to 20 minutes, it's really about the two keywords, operational and enterprise grade. And the reason I picked these two words is as we in Microsoft Canada, my team, the extended team, work with a huge amount of customers that are using innovation on AI and machine learning constantly. If you think of one pattern that runs across, it's how can we operationalize this innovation? So we have great abilities. How can we have them operational? Because that's a very important keyword for any business. And the second one, which is very important also, how can we have it to be enterprise grade? And by enterprise grade, what we mean here is for any business that is using the power of AI and machine learning, what they have to ensure is security, privacy, manageability, audit, and the list it's governance of an overarching solution that actually takes in the power of innovation of machine learning and AI, but actually included in a business, an enterprise-grade business. So with that, I wanted to jump to what is Azure AI? What is available in Azure AI? And to start with that, we have in Microsoft, we have promises for our customers and for our users. On your terms, what we mean by that is we have a large list of people who are involved in the creation process of machine learning models and AI infused in actual solutions. And based on that, you can have different altitudes of skills. So you have the amazing researchers who are actually working on new models, and you have the data scientists who are using some of the existing models and tuning them and training them for more solutions. And you have the developers and the business users who are kind of the end user, if you will, of that. The other one promise that we have is providing a mission critical. I mean, this is all based on Azure, and it's hardened to the most demanding workloads. So when we're talking about scalability, elasticity, all of the things I mentioned about auditing, managing, security, identity and access management, and different aspects, these are built in by default. Last but not least, and I think it links well with what Professor Wong was going after here, is responsible AI capabilities. That includes many of the things that we talked about, like, and we'll talk about some of that, like bias and things that are helping you interpretability of the model and explainability of it, but also the other side of responsible in AI, which is about the privacy, the compliance, and all of that. So with that, I'll move forward on what is Azure AI. When we look at what is offered on AI, on Azure for AI, it's really all dependent on the Azure Machine Learning Service. The Azure Machine Learning Service is the only cloud service that enables developers at all skill levels. So whether it's code first, or automated machine learning, or even drag and drop development of model parameterization and development, it's available. We meet every participant at their own altitude. And if you go from there, there are pre-trained models that actually provide what we call cognitive services. So cognitive services can be consumed in the form of APIs or readily available services and websites. And then we have scenario specific, and we just actually announced, so even this is not the complete list, we just announced with the Build conference more of that, which help eventual developers go directly into something like a form recognizer, which includes many of the cognitive services, many of the models, and they can focus on fixing or solving the problem that they have. So maybe the best test of any technology is the company using it, and in this case, the answer is an absolute yes. Microsoft runs on Azure AI. I mean, when we look at Microsoft team in the last few months, almost 2 million hours of Teams meetings were transcribed. If we were in Teams here, I could turn and you could turn automatic transcription and translation, and even have it in different languages. And that's an awesome thing when you start having diverse meetings that are worldwide and all of that. PowerPoint Designer, I don't know how many of you may have used that, but in PowerPoint, we use AI to help consumers, to help users of Power BI design slides, and it is built and inference using Azure Machine Learning. So actually, as users start creating new slides, having titles, and then design ideas, that is something that is using Azure Machine Learning service at the end. And of course, if any gamers are on the call, you can always have your personalized experience on Xbox. This is served based on reinforcement learning. And it actually provides over 80 million personalized experiences every day on Xbox. So again, it's not only Microsoft, it's customers. But as we zoom in quickly into the more common patterns, I will zoom in into AI-powered apps, knowledge mining, and machine learning. I will not go into all of the customers, but it's very interesting. I mean, it's all available on customers.microsoft.com. The use cases and the scenarios where our customers worldwide are using that. But let's. The reason I'm doing this, I want to run quickly towards the machine learning part. But let's start with the AI-powered apps, because as I said, I mean, if we are talking about operational and enterprise grade, some of the most important things is how fast can I get a solution out? How fast can we evolve it and iterate through it, so we can respond to the market, respond to the problems that we're facing. And with that, AI-powered apps is one of the common patterns we have. And here it's almost always a mix of Azure Cognitive Services on one side and Azure Bot Services. If we dig a bit deeper into what we mean by Azure Cognitive Services, it's really 4 main areas, and it uses the Microsoft research knowledge and research over the years to focus on vision. So vision all the way from normal computer vision, custom vision, where you can train it yourself, face, form recognition and ink recognition, and the amazing video indexer. It's one services that I personally use a lot, sometimes to transcribe videos, explain videos to me, and all of that. Speech is another area, and the language is another area. If you look at Translator, it runs based on this service, and this service is surfaced and available for developers to use directly and train directly. And of course, test analytics, language understanding. For the decision side, there are specific areas which are anomaly detection, personalizer. These are all services that are layers of pre-trained models that are using the Azure Machine Learning Service. And the beautiful thing here that we run with customers all the time is, again, I keep mentioning the word altitude, because many customers, for their needs and for their use cases, it's just right to go at this level. And for some customers, it's actually, no, we actually need to what we call a cliff-free turn into professional development. So you're not restricted to only use this. You can go and tweak it further and further all the way down. So with that, I'll run through the slides. I mean, the Azure Bot Service is the, how can I go from these cognitive services and these models into a functional bot that is actually talking naturally to users, that I can deploy across channels, and then I can scale as the load goes. There are many stories, actually, if I wish I had this in the slide, but COVID-19 introduced many stories in Canada and around the world where this became clear. Why is it important? Is sometimes the word scaling, we just use it, and sometimes scaling is the difference between a much needed service or the lack of it. So with that, AI-powered apps is a big area that we see many of our customers using a lot. When we go across knowledge mining and go into machine learning, there is a reason why I'm going in this progression. As you go into something like what we're doing here in the contest, developing the best model and making the mark is the key. It is the core of everything. But how can we take it into something that can be used at large that can be used in a scalable way, in a very operational way. So this is why I'm going through this progression. So the knowledge mining pattern is mainly about, I mean, we know how things develop from a keyword search. If you had to search for Eiffel Tower, then you got the words, and then search started progressing into contextual search. So famous tower in Paris, that would get you still Eiffel Tower. And then now the expectation is always about cognitive search. So Eiffel Tower or any variation of that is not about getting you only the text or the documents that have the text. It's about the images, the audio, and all different forms. And this is at the core of knowledge mining in Azure Search, is how can we help developers get latent insights and content, whatever the content, unstructured, structured, and how big or how large it is, domain specific, lots of things in knowledge mining services that are really important for developers. Now let's get into the area that I wanted to focus on, which is Azure Machine Learning. So the Azure Machine Learning service has mainly 4 pillars, if you think of it. Some of it I already alluded to. So like, for example, all skill levels. When we talk about all skill levels, Azure Machine Learning service has an Azure Machine Learning Studio. And literally, if you or someone else who is starting their way, or you want to just do quick experiment, then you can just use drag and drop and use actual machine learning models that you pick, change the parameter, test against data set, and then see the results, and that will help you get started. So that's one scenario, all the way to notebooks and code first experience that goes across the board. And this is the studio experience, but then you have the Azure Machine Learning Service, which connects with Databricks, Synapse, all the different platforms to help you go across. So in the other side that we see across customers all the time is, okay, now I have something that is a proof of concept, if you will. Things work. Now I'm bought in that this is a technology I want to use, that this model is actually giving me something that is differentiating for my business, or helping me in terms of, for example, fight COVID, or enhance my services to my customer. That's a good point. It's something I need. Now, how do I take it and operationalize it? I have an IT team, IT systems. I have a method that actually has a framework for security, for operationalization of anything. And here in there, MLOps is crucial. The way things developed is, now we look at customers and we find that development team and the whole DevOps journey that happened between development and IT, there is a replica of that. It's almost identical in many cases, but it's also very different, because now you have models, you have data sets that were used for training, you have artifacts of the models, and many times you need to actually keep and version these, as opposed to the development world. The also main inherent difference between them is the difference between development, where you know the final outcome that you want and you're developing towards that, and data science, where you're actually most of the time discovering your final outcome as you go. So again, how can we get that world to work with the IT engine that is actually very important and very needed for our customers? And how can we have models being reproducible, model validation, deployment? Imagine a scenario where the data used in training a model start deviating, and that happens all the time. So snapshot one, we have a model that is functioning to the level that is accepted and expected, and then now the data that is coming in that were used for training, this is now deviating. Azure Machine Learning helps you manage, monitor, analyze your model, and so you know when to retrain. Now, when retrained, there is also the build, test, and release cycle, which sometimes actually is not only the release of the model, is the release of the whole app where this model is infused in to provide the final experience. So when we talk about large customers, this is at certain points in time, this is the go no go decision. We definitely want the value out of ML and AI, but it's a no go because we can't do that. Let me share a quick example, and it's actually a Canadian example. So if you're in Vancouver, that example can resonate with you. TransLink, they are the regional transportation network in Vancouver, and TransLink uses Azure Machine Learning services for automated pipeline. So what is the use case here? And it's a public use case, so I'm not sharing any confidential information. It's really about training. I think it was 20,000 or 18,000 machine learning models using all the data coming from stops, schedules, sensors on buses, and doing that at this 20,000 models and the regularity of it impossible to achieve in an operational way. But because of the use of that environment and the dependency on Azure Machine Learning, TransLink achieved, I think it was 74 or 75% improvement in the predictions for departures of buses. And that in respect, I think it was 50% reduction in the time spent by riders. So you can imagine the value for TransLink as a business and the value for their end customer, which is us, the riders, when we are in Vancouver. So something like that is an example, and we have many customers where the number 20K models is dwarfed. Think about millions and how to manage an operation in an operational way, how the models are managed, retrained when needed, and then deployment and all of that in an MLOps way. Quickly, sorry, I'll pause here, Moin and Anna. How am I doing in time?
It's okay, Mr. Adel. You can continue for like 5 or 10 minutes. We have like around 10 minutes left.
Perfect. I'll plan for 5 minutes and leave 5 maybe for any questions. So responsible ML. I think Professor Wang maybe laid this is the area where we are trying to help. Now, maybe the difference, so I am clear, is we're providing the platform. There is a lot of work that needs to still be added to that, but with this platform and actually out of the box, gaining visibility into your models, explaining model behavior and mitigating unfairness. These are, in many cases, are out of the box. Now, of course, it's not one size fits all. It never is in this space, but you'll be surprised of how many scenarios where this can be helpful just out of the box. Now, why is that important? And again, why is it important in the context of this is a platform where, again, I will repeat, cliff-free transition into professional development or professional machine learning work is you get that benefit automatically once you start using it, and it doesn't lock you in. You can actually extend it, go deeper as needed. But if it actually delivers on what you need, then you've saved huge time, and you actually are able to focus more on what you need to do than spend more time recreating the same artifacts every time. So and again, some of the things here are a different angle to that. Think about when you're in this environment where the models are in an operational business environment, and then some aspects like lineage audit trail about every specific artifact, every piece of how the model, the metadata, and think of these things that I said, lineage and audit trail, in the context of compliance. So I mean, many examples, but basically the simplest one, when we are talking about the scenario we are talking in the vicinity of healthcare records and personal data. So I mean, there are regulatory requirements that require that. So if we're going to take your work and actually operationalize it, maybe with the government or anything, if you're going to take that and go after that, then it's not only about the success of the model, it's also about how compliant it is and how auditable it is, and then these are aspects that, again, if you have it in a platform that helps you through that, you can keep focusing on the innovation you want to do. So with that, I mean, lastly, the open and interval, and in this space, I cannot think of a much more important space where this is needed. We all know, I mean, whatever the discipline name in our customers, if it's a data scientist, machine learning expert, AI expert, we're all working in the same space, and we all know that the toolkit, the different sets of framework and languages and development tools that we use are first sometimes a barrier, because that's what I learned and I can do things beautifully with it, and I don't want to change that. So that's one. And the second is sometimes you actually can do certain things the best way using a combination of all the above, and you want to achieve that. And this is the base model of how Azure Machine Learning Service works, because whatever it is, development tools, languages, frameworks, they are all what we call first-party members of the service. It's not built for one of them. It's actually can work with all of them. So, for example, in frameworks, choosing the deep learning framework without getting logged into one, we also worked. It's an open source community project, and it's partnership with Facebook that allows customers to train in one framework and use another for inference. So again, these are all areas that are very important as you go and operationalize and offer to enterprises for real life scenarios that are working in real time. So again, I'll zoom out again. I want to share one more slides, which is kind of to the side of what I talked about so far, but I think it's also very important because it's from real life again. So Azure AI, machine learning is at the core, is the foundational element of everything else, but we do meet different use cases, scenarios, customers and developers at their altitude with AI powered apps and knowledge mining. The last one topic that I wanted to share is this, and actually it's open source, so you can go and actually look at it. It's if you go to the short URL aka.ms/confidential inference, because that's a very interesting use case we see a lot. And the idea is when you are in an enterprise setting, in a government setting, data and security are non-negotiables. So when you go after these scenarios, I mean, even if we're not talking machine learning, just basic data platform, the first go-no-go decisions about any solution are always about, is my data secure? And is it secure when stored, in transit, in use by applications? And there are very strict requirements for all of that. And yeah, we mean that. But now you get into an interesting situation where, what about if we have two customers and both of them have very interesting data sets that can be used in training models that would actually cause models to be much more accurate and much more usable? But then if we think about combining both data sets and training both customers' models on them, that would give them a much better trained model. But then you hit the wall of, okay, but this data cannot leave this customer. I mean, it's secure data and it's their customers' data, and by law and compliance, they cannot share it. And this is about this use case, is about how you can achieve multi-party inference server. It's based on Onyx, and how can you use the secured enclaves, which are hardware encryption, to actually allow for multi-party machine learning. And this is a very interesting area. We have customers, large customers in Canada, who are already working on it, and we're working with different legislative and accreditation and compliance entities that are actually seeing this as a very interesting way to go about these scenarios, because the value that you can get out of the data is being blocked by who is the owner of the data. When if that can be achieved without compromising the security and the privacy of the data, huge value can be unlocked. So I mean, this is an area, as I said, it's an open source project. It's work in progress. I know I want to make sure that this is the case, but it's very intriguing to see how the work is going in this, because the promise it holds is really very large. So with that, I think I will stop here. I probably went a couple of minutes over what Moin told me, but I hope that was okay.
Thank you very much, Mr. Elias. It was totally fine, and thank you for your presentation. So if there is any question from the attendees, you can raise your hand in the participant window, or write your question in the chat box, and we will happy to answer your question. Thank you again, Mr. Adel, for the presentation and accepting our invitation. And
thank you for having me, and it's always gives me energy to meet with this group. And I still, as I said in the opening, I'm waiting to be inspired by the results of the contest.
Yeah. And thank you very much. It was a great pleasure to have you. So I don't see any question. I just want to talk a little bit about the next phase. We will go to another website called the Spaces Chat. I will again send the link for the attendees. When you enter the room, you can there is a space like a virtual venue. You can upload a photo or just write your name, and then you can, if you move your icon close to anyone else, your audio and video will connect automatically, and it will become like you are sitting close to each other and you can talk. So as I don't see any question, I invite Diana, chair of IEEE site in Montreal, to briefly present the IEEE site and our mission, and then we will go to the special chats. Diana, if you can start if you want.
Yes, I'm going to share my presentation. Are you seeing my presentation?
Yes.
Okay. Wait a minute. I'm here. Okay. For those ones who are not familiar with IEEE site, it's just a brief introduction. And just to let you know, we have many funding opportunities for projects and for your ideas. So what is IEEE site? Is the Special Interest Group on Humanitarian Technology. It's a global network of IEEE volunteers partnering with underserved communities and local organizations to leverage technology for sustainable development. The idea is to apply our technical and engineering skills to solve local problems. And SIDE is also a subcommittee of the IEEE Humanitarian Activities Committee. There are many examples of projects already done. You can just visit the website of the IEEE SIDE Global to be inspired in many ways. We have many funding opportunities. Usually we have side projects, hack projects, events, and conference participation programs, but due to COVID, these opportunities are not available now. But the Humanitarian Activities Committee and SIDE are focusing on special call for proposals for COVID-19, and they can fund between $1,000 to $5,000. There are many areas around this, like you see here: food security, infection control devices, information and communications technology, medical devices, personal protective equipment, sustainable power sources, water sanitation and hygiene, and a new one for this call is any other issue of pressing community need, depending on the community. You have all the information in this webpage. The deadline right now is August 16, and we want to make sure that you don't need to be a volunteer to apply for this call for proposals. You just need to have an idea around all these areas and send us an email, or maybe in the networking session we're having now, we can just talk about it, and we can help you through all this process to how to apply and guide you to all the resources, and that's it. It's not necessary to be a volunteer. Anyway, we are always looking for volunteers if you want to be part of our group. So join us now, and in the networking session we can continue talking. Thank you.
Okay, thank you very much, Dano. So everyone, please join us at the virtual venue. We also have Mr. Nashlaghi, the chair of Young Professional Affinity Group in Montreal, and feel free to talk to him in the networking session. Mansour, if you want to add anything, or
Thank you, Moin, for the introduction. Yes, I look forward to see people around. Thank you. Just wanted
you're welcome. So see you all in the networking session. Thank you for now.